Hello everyone, my name is Praveen HR. I am studying at PES College of Engineering, Mandya. Now I am currently studying in 4th sem B section Mechanical. Let us discuss about Breton cycle and its efficiency and overall how we can improve that efficiency throughout reheating, regenerating or intercooling. Let us move on to the diagram of a turbojet. It consists a intake air and compression and combustion chamber and its turbine and throughout exhaust it goes. Let us move on to the working principle of open gas turbine cycle. It sucks the fresh air, enters to the compressor at the ambient temperature where its pressure and temperature are increased. The high pressure air enters the combustion chamber where the fuel is burned at a constant pressure. The fuel is burned at a constant pressure where the high temperature and the pressure gas enters the turbine where it expands to ambient pressure and produces work output. Let us see the features of the open gas turbine cycle. It can be it can be produce high thermal efficiency up to 44%. Gas turbine used in mainly aircraft and electric power generation. Let high power to weight ratio, high reliability, strong life. It can be used for a long life. Fast startup time about 2 minutes compared to 4 hours for steam propulsion system. Let us see the Breton cycles. Breton cycle is also known as Joule cycle. It consists of four reversible processes. Firstly, mainly we have to assume that the there will be no pressure losses and working fluid composition is same throughout the cycle. Working fluid is a perfect gas with constant specific heat. Let us see the pressure and volume PV and PV diagram. Pressure volume diagram. It consists a 1 to 2. It consists isentropic compression. 2 to 3 uh, 2 to 3 there is a isobaric heat addition. 3 through 3 to 4 isentropic expansion. Isobaric heat rejection. 4 to 1. These are all the PV and TS diagram. Breton cycle thermal efficiency are in the we have to use the formulas for calculation of efficiency of Breton cycle. These are all the formulas for calculate the efficiency of Breton cycle. Let us move to the main topic: thermodynamic cycles of regeneration, reheat, and intercooling for gas turbine power plant. I have taken that intercooling for gas cycle since a bulk of power developed by the turbine is used up to driving the compressor. A reduction in compression work is desirable to increase the power output of the power plant. Intercooling gas cycle is used for mainly in power plant because it increases the power output of the plant. One of the ways to achieve this is to cool the air after it being partially compressed. This accomplished by employing multi-stage compression and intercooling between the stages. This can be Generally, 2 to 3 stages of the compressor are used. Intercooling improves the thermal efficiency, air rate, and work ratio. This, if intercool is used, the size of the turbine and compressor can be reduced for the same output, or alternative generator work can be obtained from the plant of the same size. By employing multi-stage compression with the intercooling between the stages, the compression process in the compressor can be made to approach isothermal compression, which requires less power than the adiabatic compression. In the ideal state of intercooling, the fluid should be cooled to its ambient temperature. The temperature of the fluid before compression. In each stage, there should be no loss of pressure in the system. Also, the maximum advantage of intercooling is obtained when the pressure ratio for each stage reaches nth root of into root of the overall pressure. We can see that the multi-stage compression with intercooling circuit, and for that there is a pressure and volume diagram. The Brayton cycle is mainly dependent on pressure ratio. Thank you for the giving me. Thank you for the giving me to present this wonderful. Thank you.